Okay, hello everyone. Thanks for coming to this presentation. Practically with this presentation, I'll showcase some of my work in the past. With this presentation, actually, we will try to different perspective of games. It's we usually think that games are only for entertainment, but using game engine, we can do a lot more than that. So I'll start a few things.
There's a little clip on it.
Okay, yeah, I'm used to the other mics.
Yeah.
Okay. Like a porter with us. Okay, now can you listen?
Do you do mine?
No.
All right, try
Okay,
now.
now can you hear me? Not that much. I can speak louder.
There we go.
Yeah.
There we go.
Okay. So first of all, I'm really happy to have joined recently Purdue. Some words about my background. Just want to keep that. I'm a game developer myself. I'm a hands-on developer, so I'd like to build stuff. And over the years, I'm an ECE trained engineer. I hold 2 PhD titles in electrical and computer engineering. And I also have a serious game design and research certificate by Michigan State University. I was happy to be selected at MIT for the IoT bootcamp back in 2017. And I also was an instructor at the MIT Deep Tech Bootcamp in 2019. And for many years, I was working at the Lab of Educational Material and Methodology in Cyprus at the Open University of Cyprus, and I specialized in distance learning. So I practically built tools for distance learning education. So we will see a lot projects from my works over the years. So what this presentation actually includes, I will share a bit of my story, how I started and why I do that, and how I work in the interdisciplinary way. So we'll have many hands-on projects in the publications for them, and actually what was the impact in a series of industries, especially education. And I will try to prove with all this presentation that we can have a multi-technology fusion. So we can use multiple technologies that we think that are isolated, they are independent, but at the same time, they can work together even a domain agnostic and provide a domain agnostic impact. So regarding my story behind the scenes, I started from the National Technical University of Athens, which is an engineering school. It's the toughest in Greece. But at the same time, although we were very technical in terms of our education, I always loved the creative stuff. So even during my freshman year, we set up a team with some other friends, students there at NDUA. And we actually, in about 2 years of development, we created the first turn-based and real-time strategy in Greece. Imagine that back in the day in Greece, and even at our university, when we discussing that we are trying to be game developers, being a game developer was similar to just play games and lose time. And professors actually told us, you will fail in your exams. Don't you use your time in playing these kind of things. But at the same time, even though it was a student-centered project, and actually it was not advised by any professor at the university, we managed in just 2 years of development to actually release that. We found a publisher, and we've been through all the process from designing, developing, releasing, and supporting a game to the public. And actually, it was something that we did not expect, because I want to be honest, it was not the best game, comparing to the AAA titles out there. It managed to be a bestseller. It managed to be a bestseller in Greece due to the fact that it was a niche game. It was something about the Greek Revolution. It was in the Greek language, so there were no games actually in Greek. So the people actually, loved to buy our game back then. So we had a revenue in 1 year more than 200,000. And actually, with that, one of our great accomplishment is not the game itself, but we actually did community building. We found other developers that were trying to make some impact in the field in Greece. And we did some conferences back there, and we actually started something that, there is this kind of industry in the country. And due to the fact that it was one of the first efforts, we actually attracted mass media. And for specific months, we even our game was first in charts even among the AAA titles in Greece. Imagine back then the difficulties that there are no Steam, no Play Store, stores that we could publish online. So we even had to create a CD. We have a CD to reach our audience, and having many mediums in the process, it was difficult because everyone wanted to get a cut from the game. So although there were some difficulties, we got much experience out of all that. But as I mentioned, I was still an undergrad when I was doing that. Although we did not have game development programs, I was into the sound part of this game. I really loved sound, so I found a professor and I told him, okay, we don't have games, but let's do something with sound. With that, my experience was into electronics, so we actually did a custom D-class audio amplifier. So I did a lot with microcontrollers there. I graduated and then worked in the industry, and I worked, although I was into hardware, the CSE part of it was actually a section of our studies in ECE. So we did also a lot with programming and stuff like that. So I then end up being in the industry and being a software engineer, and actually did a lot with APIs and customizations, even for large corporations like Cisco and Logicom in Cyprus. But at the same time, I never stopped working. I did a lot with game engines. I moved to Cyprus. I organized the first game exhibition event back there, and I was still working at many elements of game development, including extended reality. So yeah, I know some of you may wonder about that. So we talk about games, we talk about microcontrollers, hardware, XR, games, and all stuff like that. Yeah, at that era, I will be honest with you, it was like a weakness because it felt that where do you specialize somewhere? It's what would you like to do? But at some point, it was like an epiphany to me that all this could work like puzzles and create impact by combining different kinds of knowledge and different kinds of elements in order to create even more impactful applications. So the first actually, my first actually project that combined that was at MIT in Boston, where I combined game development with XR, with plugins, and I also had APIs with authorization methods like Auth 2.0 for security and get the tokens and get the information. And this also connected with IoT and sensors in order to provide the real world with sensors into the virtual world with gamified tools in order to create an application. So it was like an IoT-enabled AR. So practically, I recreated the project there. I did, where I led my team. This was a tracking image. So you see there was some animals at MIT. Our teams were animals, so I think it was team bears, my team. So practically, we had a tracking image. You can see here the output. You could see that the animals became live. And at the same time, you could see here there is a candle. So I had a temperature sensor that got the data into the microcontroller. From the microcontroller transmitted the data to the cloud. And from the cloud, via secure authorization methods, we got this information inside the game. So you could see that the temperature was changing live inside the game. So when it reached a certain threshold, imagine there was Chuck Norris that was appearing and was fighting the lion. So it was a fun project, but actually it proved that we can get the real world into the virtual world, even in low latency. So we can acquire real data into the virtual world and actually trigger things inside this kind of application. Imagine an expansion of that, play some games, for example, sports games, and You could have specific sensors, for example, let's say FIFA soccer game, a la FIFA games. And actually, let's say you're playing with your friends and suddenly outside start raining. And because it's raining outside, it will rain, in your game based on sensor data. We could do that. Coming up next, I will showcase many of the projects I did over the years. The project I was talking about was this one with the tracking image, how the augmented reality objects were appearing, and this is the temperature sensor and all these the dashboard data that we're importing in real time in the virtual world. Coming up next, these are some of the collaboration at Open University of Cyprus that I was hired many years, Michigan State and National Technical University of Athens, MIT, with India, IITM, IIT Madras, and also the Hellenic Air Force Academy. These were some of the collaborations that these projects that will showcase soon. So I did a lot about games and specifically about serious games and gamification, because one of the most engaging ways to approach education is gamification, because you provide the means of students not to have static material, but actually do something and interact with the material. So this is something that a huge advantage that gamification provides. And also I use Nicole Lazaro. This is the designer, a great designer in the field. And actually the serious game provides the sort of serious fun. The serious fun actually is a fun that is not only for entertainment, but actually creates something. And by playing, you do something meaningful, something impactful. And also, generally speaking, with virtual environments and games, actually, we offer a sense of virtual embodiment. So the characters that we create inside games, actually, it's like a real extension of the real person to the virtual world. Coming up next, I will dive deeper into hands-on tools. This was actually for environmental studies. This is how we started. It's like we do that in class with my students, and so many of my students here. So practically when we start designing, we say, oh, this is the sketch, the first thing that we do, what we will include in our games. And actually this was a meeting I had with other academics from the environmental studies program. And actually we discussed what was the problem. The problem was that at OUC is a distance learning institution. So the students could be anywhere, could be in Cyprus, could be in Greece, could be anywhere in the world. And one of the projects of the students' main project was to acquire data from a forest. But as you can imagine, not all students could have access to this kind of data. So, and also it was unsafe to send them to the forest, because if something happens to the student, the university would be responsible. So I suggested the idea of creating a virtual tool where they could move around and they could actually take screenshots in order to do their project. And also it would be the common ground, let's say, because we could assess with the same areas the students in order to provide, the same rubrics of evaluation. So after we established that, we designed the main features. We would have a virtual ecosystem. We had first-person movement, compass, local coordinate system, minimap, and I will showcase the IoT implementation that I created. So this is how I will showcase the project. You will see a video, and also you will see some of the publications down there. Starts how it is. It's better showing that. So it's a first-person game, so the students could move around. There is a virtual ecosystem, forest ecosystem. There is minimap, but at the same time, it's like we have a drone system. It's like a major max map, let's say, with different heights. So it's practically giving the opportunity to students to acquire, a screenshot. Let's say I went to this exact coordinates and I got this picture there, so I identify what the project needed. Yeah, one question was if they die, if they go underwater. No, they don't die. It was, just a representation because, at some point we may add, fish or other animals there. And we also have a teleport system, so we could move to specific location. And here is one of the main elements of the project. Up until now, the project is for asynchronous learning. So the students could download this tool and they can work at their own time, at their own place, on their computers, and they can do their projects. But at the same time, I was thinking, and I suggested the idea that since we also have synchronous, courses and classes, why don't we use these kind of tools for synchronous learning? And the idea was that if I provided a tutor with a microcontroller, and in here, instead of a sensor, we could have a button, a simple button, which is an on and off switch. So the on and off switch could send that to the microcontroller, and the microcontroller could submit that, send that to the cloud. And from the cloud, we could get this information inside the game. And why we could need that? Because imagine that the on-off switch could trigger events inside the game. And one good question would be, and why can't we do that with a simple keyboard? Because this way, it's like we would have a serverless application, and every student on their computer that are online, they could visualize from any angle these events. So it's like a pseudo, I named that a pseudo multiplayer event, because the students do not see each other, but at the same time, they could see the trigger events within this virtual world. So what we did see here, we saw gamification and game development. We saw APIs and authorization methods, and we also saw hardware and IoT combined together to create something for synchronous and asynchronous learning. So what we do the same, but we add also an XR element, but we do that for a different context. We could do that for avatars and digital twins. So in here, we could also create augmented reality application, virtual reality application, and desktop applications. But actually, we could simulate and get information from real cars in order, for example, the speed and the RPM from the dashboard of the car. And we could get this information and visualize what would be to be in the car. So practically, it's like, let's say you have the Uber fleet and you would like to attend how every Uber actually drives itself. And this actually was from MIT. It automatically creates the map based on the location that we were getting from the car. And at the same time, we would have the speed and RPM. This was the AR part. We would have also the VR part. The VR part could be, it was a simple Google Cardboard, but imagine that it could expand obviously to higher resolution VR. And we actually play with a dummy file for that. So we added location. So in here it goes in Paris. So that's why you see the Eiffel Tower, because we put the coordinates from there. And also we would have a desktop application. So we would have several cars like monitoring tools. So you could see, for example, the whole fleet of the area, getting all this information in real time, or low latency. Imagine that you'd have a latency of 2-3 seconds, and you could visualize how every car is operating. Coming up next, I'll talk a bit about photogrammetry. It was another piece of the puzzle. This is an image from Quixel Megascans. Photogrammetry is actually, I know we have some experts there. It's bringing the real world to the virtual world. But this time, you have multiple photos from different angles, and you create the 3D models in order to create the real object in the virtual world. So in here, it was again for education, but this time for humanities. Actually, this tool is used by two programs of study. One is the Hellenic culture, and the other one is the theater studies. So it features an actual ancient theater in Greece, in northern Greece, the ancient theater of Philippi. So in here, imagine, although it's a game, it has also web tool elements, and actually it's web development because we get all this information, we store that, and we use that later on. Because it's a tool that not only showcases stuff, but actually has educational assessment within the tool. So practically, we had 4 different levels. The first was the architecture. I collaborated with a company in Greece. It was about 5,500 photos, both close-up and from drones. So the students could move around. It's the actual theater, as I mentioned. So you could see the different areas of, there's invisible colliders there, and you could see what's the part of the theater that you are moving along. It also has chunks of lecture within the game, so the professors could actually appear within the game and present the main important things about this level. So imagine that a professor could say, okay, this is the level, you need to read this material, find out a bright space, for example, and come back. There are hotspots with questions. You need to answer these questions. There are multiple choice questions. And if you have an over 80% correct, you can actually pass this quest and pass this assignment. And at the same time, one of the key elements of this tool is, first of all, that's a web-based, so it's a WebGL. So especially for humanities students, it would be difficult to have executables and have this kind of stuff. And so it runs in a, just a link. We provide them a link to run this game. And at the same time, you remember, as I mentioned before, that we collected all the information, student names, the program of studies. And after that, in here, they just press S for submit. And this game actually automatically connects with a Google form. The Google form actually gets all this information, the score and the name and all this kind of stuff. And it automatically feeds a Google Sheet. So the professors have all the scores at one place in order to get the assessment for each level of the game. So possible expansions of that. We could even not only work for education, but we could actually resurrect an ancient play, for example. We could have actual actors play, and act, let's say, an ancient play, a drama, for example, and we could have mock-up. I know my friend Dan is working on that in creating stuff with mock-ups. So we could actually have a real visualization inside virtual worlds and even have an interactive play. So practically imagine, because you have a gamified world, you have actors with avatars, and you could actually change the clothing, change stuff, within the theater, and possibly create, an ancient play and a modern play of the same time. So you could actually play with that, and actually we can even create the so-called non-linear gamified cinema. So we could have different endings, different stuff. We could have a non-linear play using gamified elements. Again, for humanities, we could even have data and images and text within gamification. So we could have like virtual exhibitions. So we can have photographs. We could have even artifacts that we could create our own exhibition within games. So it's not like a gamified tool. It's presenting our work through games. But at the same time, the most important thing about this tool is that whatever you see inside this game, it's actually not inside this game. All this information that you see, all these images and stuff that are populating, including who is the author, who created this image, they are all in external directories. So we populate these directories, and when we open the application, it automatically creates a new exhibition. So it's like we could be art curators, and these here are the slots of the artifacts. These, I didn't populate everything, but as you can see, this is something that when I put some extra images, automatically it would create a new exhibition. Coming up next, in totally different domain, in waste management, we can even have even more advanced data, not only images and just text. We could even have research data. So in here, I think some of you are more into field research. These are some from papers. We could have different kinds of data that we could use in order to create at this time monitoring tools. We could have monitoring tools that can be used both by students and external stakeholders. So we could have an area, for example, here, let's name it Athens. We could be West Lafayette. We can add information about the KPIs, about the real situation in our city or municipality. And after we import all the information that we have, we actually have the strategies, and we start the game, and we actually virtual monitor a virtual city, and we see how it performs in terms of waste management towards creating a green city, for example. Have we followed the strategies that we need? Have we can we do special, actions that could benefit our community in terms of waste management? I know that in the department now we also have cybersecurity. This is a game for cybersecurity. So in here we have game development that actually connects with the real world and virtual machines. So in here, practically, the users, the students actually become the hackers. They become the hackers and they try to escape. They want to acquire, different passwords. Every time is a different password. So it randomizes the passwords and the passwords are encrypted. Also, when you start this game, actually it connects to a VPN. I program it to connect to a VPN. And at the same time, it has many technologies inside within. In fact, that we can have an inventory, we can have, for example, a USB that we need. We have also video streaming. That video streaming can be within the game or can be a video that we stream from the YouTube. And then the most important thing, after we get in this room, this is the second password, and we need to identify the third password in order to escape. We are connected to a computer. By pressing this E button, we actually leave the game and go to a browser. And from the browser, we are connected to a virtual machine where actual penetration testing takes place. And we get, they do, lots of cybersecurity, training, penetration testing, red flag testing, and stuff like that. And after they finish that, if they are successful, they get the final password to get back to the game in order to escape the last door of the game. This game had also single player and multiplayer. The multiplayer were actually, who wins. So two students are in two different rooms, and the winner is the first person that will manage to escape. Coming up next, what if we combine gamification with virtual AI? So my idea of that started from an exercise that the professor had a problem with that because the student did not understand. And we tried to make that more, student friendly. So the Oracle numbers actually represent a game. It reminds somehow Mastermind, if you know the board game. So practically, the Oracle, which is the computer, actually provides three prompts, these three prompts here with the yellow, which is zeros and ones. So not all one numbers are correct. So the students need to identify what's the correct prompt, starting from this prompt that they got from the Oracle. And the Oracle, every time they submit a new idea of what the correct prompt is, it replies back. So actually, the students, there are two levels. The one, if they identify the three prompts, they can, the students need to understand the mathematical perspective of that. So if they manage to do that, they again test if they find the correct prompt. And my idea of that is that what actually this number means, for example, for engineers, what could be 0, 1? So the most, the easiest way to think about that was on-off switches. So I suggested, why don't we have virtual Arduinos with buttons, and wherever the spot is, 1 from this prompt, the students need to press this button. So the students actually understood with that we could find the three prompts and we could identify which actually buttons needed to be pressed. And if they are successful, there is a virtual LCD monitor that says congratulations. And this is a project actually, and then they submit that. And similar to my other project, they submit all this project, again to Google Form automatically and Google Sheets. So again, the professors have an excellent view of what the students did with this exercise. And I'm going to AI part now. I know we have with Victor with the AI part of our department, but one thing that I asked my students in class, what do you think about games in AI? And the most common answer was, games with AI are probably non-player characters. They are the AI, that we don't control, but they are within the game. But what I showed them was that it was not the only case. So with games, we could actually create data, synthetic data within the games in order to actually train real AI models. So the buggy simulator was actually a gamified tool that could have user input or even rule-based AI, create synthetic data, and actually train a real AI. And that happened all with a game. So practically, we had this virtual buggy that has a camera within, not only the game camera, but another camera that simulated the real camera of such a buggy. And we actually create a CSV with all this information, the wheel angle, the steering angle, the point of view, and actually the XYZ of this screenshot. So we had a solid information about what the buggy sees and how it operates. And using this information, we exported data that then my team at MSU created a convolutional neural network and a real buggy, a self-driving vehicle there with a similar, track, and actually started operate itself. But let's see that. Actually, this is how it looks like. So we could move around. There were invisible colliders. You can see this camera that was the sampling camera. We have the speed, we have the pedals, and we have the wheel angle, how we were turning our car. And at the same time, I don't know if you notice the differentiation in lighting. The differentiation in lighting is that I used a methodology to scale up the data I was acquiring, because in fact, I could have a really clean asphalt, but at the same time, I used Perl noise in order to differentiate my data. So every time, even we had the same lab that we were acquiring data, at the same time, every lab, we acquired different data because it had different noise while we were moving around. And using all this data, all this information, you could see that the real buggy started moving itself and stayed within the lines, only using the information that we had provided with the game. And after doing that project, a next step would be if we can do that with low polygons and simple FBX models. Why don't we do that for real sensors? And LiDAR is actually a sensor that is used in the industry for self-driving vehicles. And we discussed the idea of, instead of creating the AI model, can we validate data, LiDAR data, synthetic LiDAR data that we can generate from a gamified tool and actually validate that with an AI that it was trained with real LiDAR data? And that's exactly what we managed to do. In here, you can see that practically we have an options panel, and this options panel actually provides information that we can acquire from LiDAR datasets. So practically, we can simulate any kind of LiDAR with this, within these games. And practically, by starting that, in here, you can see there is a car, and there are some other cars on the right side. So practically, when I did this sampling in order to create the point cloud data from the LiDAR, in-game, since we know the ground truth, we acquired segmented data only for the cars that we needed. And we had an AI that actually is used by Uber to track cars, And when we got this CSV file with all this point cloud data and we validated that with the real trained AI model, it actually found that there are cars there, but there were no cars. There were virtual cars. So what did we prove with that? First of all, we made fun of the model. The second part is that we proved that we can create this kind of synthetic data that are good enough in order to actually train hybrid AI models that use real world information and synthetic information. And why we do that? Because we could cover edge case scenarios. For example, having data from the LiDAR, we can go around the streets and get this information. But for example, we cannot find a flaming car or a car that is flipped. But we can do that easily within the game. So we take all this information from the real world and we can add information from the virtual world in order to create more advanced AI models. Again, I know that we have also members that they do raise awareness stuff and UX, so we could actually build tools that raise awareness for a series of matters. This is again about self-driving cars, but not about the self-driving cars itself. It was about the pedestrians. So how people perceive the self-driving cars when, for example, crossing the street. We made this user study. This actually was user study in order to understand how people perceive the self-driving vehicles and if they felt safe to cross an intersection, knowing that a car is self-driving or not. So some crucial information that we noticed is that when they don't know, they are afraid. When we added a special light that the car notifies that I see you. So they ended up, and by knowing that they see you, the car stopped. That was the scenario. When they knew that, the users actually ended up abusing the cars because they say, okay, I will cross. It doesn't matter if it's not, I have a red light, it will stop. So we noticed all this information. And actually, since we ran that in different countries, in Greece, in Cyprus, in the US and Pakistan, also we had different, we noticed a bit differentiation of the approach of the self-driving vehicles. Again, in order to raise, awareness and see the behavior sampling in the virtual world, I collaborated with the Hellenic Air Force Academy in order to create a drone simulator. And I was happy to have real trained pilots test this application. So practically, it was a civilian mission, so that's why I had the ability to do that, because military is military, as you know. So practically, it was a civilian operation that we wanted to see how drones actually, the drone operators react in time, in a time sensitive missions. And I had, combat pilots, I had air defense controllers, and I have engineers play this game. And the story of that game was actually that we sent, a team, a rescue team, to see what happened because there was a gas leak. And this rescue team never came back and never responded. So there was a hazardous situation, and they said, let's send a drone in order to identify and find where this team is. So practically in here, it was to locate an orange car that represented the car of the team. So it was controlled by a PlayStation controller. We use that in order to simulate the idea of how, a real controller of a drone, a tetracopter drone could work. And one of the major, observations that we had, because I think we had 25 pilots. It was 18, 19 years old. And the 22 first that completed the mission were pilots. So even in virtual world missions, the pilots were even the better choice to play and actually be virtual controllers of the drones. So again, an expansion of that. This was a mission that actually was in an imaginary place, but using, for example, TerraLand with Unity or Cesium for Unreal and other kind of libraries, we could actually have missions in the real world, from the real world inside the virtual world. So, for example, in here, we could have specific coordinates, we get the height maps, and we get all this information inside game engine. So imagine that we could do missions, drone missions, for example, or self-driving missions, and get the real world information inside these worlds. But again, we have lots of stuff, gaming, development, gamified. Let's combine that with hardware. It was an idea of this reptile museum. I did that for the Researchers' Night. A Researchers' Night is an event in Europe, pan-European event that happens every September, and all the universities can participate, and school, students can come and attend, different kind of projects that are going on. And in here, imagine that I create a game that's a 2-monitor game. The one was the control screen, and the other screen was actually the screen that creates the illusion of a hologram. So in here, practically what you can see, it was a pyramid, a glass pyramid. And at top of that, in here, there is a TV. So it's a TV that reflects this information to the glass, and it gives the illusion of this of this animal. For example, we had a turtle and a lizard. They were actual animals from Cyprus. These animals were created with photogrammetry, and the animation was mock-up. So we had all the information about these animals, and actually you saw these animals moving within this glass. So it appeared that for the students that there is an animal in there. We could actually gamify services. This is a virtual library, another project that since at OUC, the students can live anywhere. They could not go to the library because there is no library other than Cyprus. So for example, students that we have in Greece, they could not go to the library. So I created a tool that actually has all the links of the library to attract, to find journals, to find the repositories of, the thesis and all this kind of stuff. And they can move around in a virtual library environment. So when they approach that, they can press a button and automatically transfer to an external browser. So it connects again, it connects again the real world with browsers, which is difficult to understand what's the one, what's the other. We have all the information, even the educational material is there in order for them to actually have a sense of going to a library. A new project actually that finished not long ago. It's a virtual courtroom for law degree students. Actually, they could move around and they have specific hotspots. And I intend to publish that next period. So practically, they could move around and they have specific areas of the courtroom. So practically is we give the opportunity to them to have like a tour without going and staying at home. And actually, this is also browser-based. And just to sum up a bit, for me, it was all about games and gamification. And my first epiphany was that this can be combined with other technologies like the Internet of Things, like AI, and all these surrounding technologies. So we could have photogrammetry, we could have GIS, and you can name it. We can have different sorts of technology. And by that, so we can create our own elements, let's say, if we go to physics and chemistry. And not only we can have our own elements, but we can provide impact to different kinds of fields. As we saw before, you saw about the industry, self-driving vehicles, you saw cybersecurity, you saw education in general, law. So it's like a domain agnostic, depending on what we like to do. So again, I go back to my puzzles. The thing that was my weakness, at the end of the day, I thought that you could, find the right puzzles and create, meaningful applications. And again, all these puzzles are for me. I know many of you have different puzzles that you can combine, or, with synergies that we can do together, we can add our own pieces in order to create impactful applications. So just a few things about my next steps. I would like to, in here at Purdue, I would like to establish my own lab about serious games and how they can be combined with these advanced technologies. We submitted a few days ago with a team at Michigan State a publication, and I will also proceed with 2 conference publications about the virtual courtroom and the Oracle numbers. I intend to create a course actually on serious game development and research, and I also arranged an industry talk because I want my students to actually be close with the industry soon enough. It will be about game engines and how they could use markerless mockup in order to create, animation within their games with using such tools. And this is an upcoming student project. This is from Tony Wang. This is an undergraduate student that came to my office and told me that I would like to do some serious games. And I told you, what course do you like? And he was looking at me and I said, what high school, for example, course did you like? And he told me physics. And I told him, okay, so what do you know about Thomas Young experiment? And he told me, I know nothing. Great, that's a good opportunity. So the Thomas Young experiment was actually in physics that it was a diffraction experiment that proves that light is not only behaves like particle, but at the same time it behaves like waves. So in here, we will reconstruct the whole experiment, but in a virtual world. And we actually want to test it afterwards on engineers. And because I was taught that in ECE. So if we have that, we could actually have a tool for them to actually play and see how it works and how have bonds with bright light and then with no light, and see how our light behaves in, this is an Unreal Engine, for example. Thank you so much. Hope you enjoy some project, and my goal for that was to understand this fusion and also explore synergies. I know that I've talked with some of you, but I'm sure there are much potential different puzzles that I have not included, that the puzzles, and all together we can identify opportunities to create some really cool stuff. Thank you so much. If you have any questions regarding the projects or stuff, I'm very happy to reply. Yeah, I was looking about that,
It looked like the ruin where you were saying there's another company where you had drones and everything. How you also made a comment where it's sometimes you're going to an external source, you interact with one thing in the museum and you're actually seeing images, lectures, whatever from other people.
Mm-hmm.
For the arena part, was that all internal? That was all a part of the game. That was no external.
You mean the ancient theater of Philippines?
Yeah.
Yeah. It was all internal. It was all internal. The information there. Practically, the thing that could be changed was the questions. I had a JSON file there I created question banks. Okay, so the question banks was, we had 4 different levels, so we had different question banks for these levels. So every student that could play that game have different questions every time. So they could not cheat that you find the same question, the same for their assignment. So this could change. We could add questions or remove questions. And that was something that was external from the game. But other than that, all the other things were inside. But for example, the videos could again, be streamed from outside, for example. Mm-hmm. Yeah. Yeah. Any other questions? I don't know if we have any questions from, online or something. Great, we don't have. I think, I think everything is solved, I guess. So, yeah, once more, thank you. And, okay, sorry.
Thank you.
Thank you.
I just wondering, like, for example, if I am basically competing with the English language, or a game with English language and will be unstable with it.
Let me show you that. Too for the game. You see here, we can move around and we could have, the idea is that you could see the various exhibits, and at the exact middle of the screen, when you press the mouse click, the left mouse click, it automatically transmitted array. It was array casting. If it found a game object that was a slot for an exhibit, it automatically create a GUI here that showcase this information. So you see here, first of all, it was somewhere like here when I pressed that. So you see the exhibit here, you see the section of this part of the exhibition, and underneath that, you see the name. All this information are stored within the file. So the files is named, for example, Georgios Pappas, and I have also the Greek name, and it's in a subfolder that is called time. Okay, so it gets all this information from the outside world. So answering to your question, by pressing a button, it's actually the L button. You will see here, it says cultural policy and development. Okay, so by pressing the L button, all this information automatically translates to Greek, even the exhibition. So I have all this information stored in a way that, for example, I had Georgios Pappas dash Georgios Pappas in Greek. So it took the first part of the sentence and then it took the second part of the sentence. So it was all in a file naming, but I made it in a way that when you change the language, you actually get the other part of the file directory, and you can do that multilingual. tools. So this is a bilingual tool. Also, the virtual library is a bilingual tool because we have students that are, foreigners, they're not Greek speaking. So yeah, you can have all this information, all the education material, both in Greek and English. So yeah, it's doable. And the way, generally speaking, the companies, the industry works in this section, actually they have like Google Sheets, and they have all the information that they need, and they have all the language that they need. So they communicate, the game communicates with this sheet, and depending on which column they want, which language they want, they get the relevant information that they need. This is how it works in the industry. Yeah.
Thanks. One more thing.
Yeah.
Nowadays we have all the
All the?
large language.
Yeah.
Mhm.
Yeah.
You try like.
Yes, I know how to do that. I started the project just before leaving at the previous university. Practically, it's an integration, it's an API integration. Okay, so you could have the game, the human to AI interaction, the Oracle numbers. I built the knowledge like it's not a large language module, but it's like an AI within the game. But imagine that you could have APIs, the APIs I use that in the industry, what I built that, but you could connect that with token with, for example, ChatGPT. So you can communicate within the game and get answers from that. And actually, you could have the text, but there are tools like lip sync, and you could have like a model and actually talk the answer of ChatGPT. These are virtual agents. I think this is the Christos area. Christos does exactly that. But it's doable. It's not nuclear physics. It's something that, can be done.
When you're doing the large language models, can you give it, if you're doing something in the museum, you want to give it the information. So
You can train it yourself to have your own data. So for example, you could have a custom large language model that knows to speak the language, but to not have the specific model, the specific knowledge of what you wanted to say. So you would have a custom one, or you can connect that with a large language model that's pre-trained. So for example, you could feed it with documents, PDFs, but I need this model to know this kind of stuff only. And you can have this communication, this conversation with the AI model within the game only with specific data or with broad data.
It's very risky to have the general version. You don't know what you cannot predict.
Yeah.
Might be better to fine-tune it.
Yes, it's more controllable to have your own data there in order to have. And practically, you need an AI model that knows how to speak, but does not know anything what to tell you. So that's, you have the communication, but the data should be yours in order to get, the information and do your research based on what you are trained, what the model is trained to do. Any other questions? Okay, so thank you, and I thank the students that were forced to come here.